In the next section, we're going to talk about binomial probability distributions. In binomial probability distributions, the key word is the bi in the binomial. Remember, what does bi mean? Well, the prefix bi means 2. So with binomial probability distributions, we're going to be looking at distributions that have 2 possibilities, 2 outcomes. So, what are your 2 possibilities or outcomes? You can kind of think of them as success or failure, winning, losing, getting something right, getting something wrong, that sort of thing. It's going to be looked at as a game or an experiment that only occurs a certain number of times. And your probability of succeeding or winning is going to be the same each and every time you either play the game or do the experiment. So we're going to look at, first of all, just identifying a couple of values for our problems here. First of all, we're going to use 4 different letters. So N is going to be the first one. We're used to seeing N, though, a lot. N is just going to be the size of our sample or how many times we're doing our experiment or playing our game, that sort of thing. P is going to be your probability of success or winning or getting something right. Q, on the other hand, is going to be the reverse. It's opposite, the probability of failing or losing. And our last little value that we're going to be talking about here is X. And X is going to be the possibilities of how many games you could win, or if it's not a game, success, whatever you're considering success. Those are your options. So let's go through an example and figure out what our N, P, Q, and X are first. Then we'll worry about later what we're going to do with all of these values. So this first example is up at the top, has us pulling out a single card from a deck of 52 cards. If you select a diamond, you win. Otherwise, you lose. Repeat it 5 times. This experiment has the following. So what we want to do is we want to list out the following values, the N, P, Q, and X. Well, first of all, N is, again, the number of times you're doing this game or experiment. Well, we said we were going to repeat this 5 times, so we're going to play this game 5 times. So our N is 5. If you select a diamond, you win. So success here is going to be considered if you select a diamond. You're going to win. Well, what are your chances of winning? Well, there are 13 cards in each suit, or in diamonds. So there'll be 13 out of 52 cards that are going to be considered winning cards. If we turn that into a probability or a decimal, that'll be 0.25. So that means you've got a 25% chance of winning. Well, Q is what are your chances of losing? Well, if we've got a 0.25 or 25% chance of winning, our chances of losing is everything else. 1 minus the 0.25, which will give us that we've got a 0.75 chance of losing, or 75% chance of losing. And the last values we want to talk about is X. What are our possibilities for our 5 times we play the game? Well, and again, this is talking about our successes, meaning our winning. Well, in this game, we could win none of the games, so that'd be 0. Or we could win 1, or we could win 2, or 3, or 4, or we could win all 5. We can't go beyond that. So you go from one end of the spectrum, which is you're not winning any, to all the way up to the top, you're winning all of them. Those are your options. Now, what we want to do is actually do something with our values, our N, P, Q, and X, and find some probabilities and build one of those probability distribution tables like what we did back in section 5.1. We can either use a table or we can have our calculator kind of do these problems on the fly, which is going to be your best bet. So we're going to use a different part of our calculator that we have not used before. and it's called the binom PDF. And the PDF stands for probability density function. I just think of it as looking at the P, probability. So, to get to the screen where we can find the binom PDF that's going to calculate all these probabilities, you have to press the second button on your calculator first, which is usually yellow. And then you're going to press the vars key, and then you're going to arrow down. You're going to keep on arrowing down until you get pretty far down at the number 0, which is the binom PDF. Be careful. Notice underneath it, there's a binom CDF. We are not going to use the CDF. The C means cumulative. We don't want to do that. We're just going to do the PDF. So what happens if you press enter after the binom PDF is your calculator will only display this first part, the binom PDF with a parentheses. You have to enter in everything after that, which is we have to know what order we're going to be entering in things too. Usually most of the calculators don't tell you what you've got to order it, what you've got to put input and in what order. What you need to do is you need to input your N first that you're going to use, which is the total number of experiments or games you're going to play. So it's going to have your N first. Then you've got to enter in your probability of success second. That's your P. And then whichever X you're looking for the probability for first. So on this first example, what I did is I used an N of 8, which means whatever game it was or experiment it was, there were 8 trials or 8 games played. The probability of succeeding or winning was 50-50. And I wanted to find the probability of actually just winning 3 out of the 8 games. Then I have to close off my parentheses. They don't do this for you automatically. And then when you press enter after that, it has a value that it outputs. And that is a probability. So this is a probability of winning 3 out of 8 games if your probability of winning was 50-50 or 50%.